Leverage classroom instruction and technology for ACT success. Hi, I'm Tom Reardon, math teacher from Ohio. All materials can be found at this website, all lowercase letters. Press pause if you need to write that down. The ACT has 60 problems in 60 minutes. That's 1 minute per problem, right? No. The problems get more difficult as the number of the problem increases, a direct variation, if you will. So we suggest the following. The first third problems, try to do in 30 seconds or less if you can. The middle third, try to do in 60 seconds, which gives you about 90 seconds on each of the last 20, which you might need. So 30, 60, 90, where have you heard that before? I want my students to be able to do these problems by hand, and even though they can use a graphing calculator on every single problem on the ACT, I want them to be able to do them by hand. However, this is a big however, on a high-stakes exam like the ACT or SAT, I want them to take advantage of being allowed to use a graphing calculator legally. So my in-class assessments usually have a green go calculator part and a red no calculator part so I can make sure they can still do things by hand. And on the ACT, I want my students to be very comfortable with the graphing calculator and use it effectively and efficiently. Again, all materials are here. We will be using a TI-84CE. You could also use TI Inspire or whatever other graphing calculator you want. How this video will work best. You may want to download the PDF of the ACT problems that we'll be doing, print it, and do your work right on that paper. That's not necessary, but suggested as the problems will be up on the screen. The PDF is again located at this website. I will show the problem on the screen and ask you to pause the video to read the problem and solve it. Resume when ready. There will be a 4-second delay before I show the solution, so pause quickly. It is suggested that you do the problems before looking at my solutions, but hey, that's up to you. Pause or rewind the video at any time. Have this work for you. There will be problems that I will not be able to do in the allotted time, so the solutions for all the problems is going to be at that website above. And also an extra video explaining any questions that are not covered in this video will be available at the website also for you. So this is the website or a partial of it. Okay, on the left side you'll see a PDF problems on the video, slides of these problems and solutions, and other things will be there. Okay, so from now on you will not see me, but you will be able to see the problem. So here we go. The first couple examples will deal with Lcm and Gcd. So this is the first problem. Pause the video to read it, solve it, resume when ready. So recall that the least common multiple is the same as the least common denominator. And so these are the directions on how to use the calculator for this. So let me bring up a calculator here. So under the math key and over to num, number 8 is the LCM or least common multiple or the least common denominator. Now for this one you can only do 2 at a time. So to get around that, how you do that is you would do the least common multiple of 60, comma, and then another least common multiple, math over to num, and number 8 least common multiple of the other two, 70, comma, 90, double right parentheses. So you're going to find inside out will be the least common multiple of these two numbers paired up, that answer paired up with the least common multiple of 60, and the answer is 1260. So let me peel that off, and so the answer is J. Press pause as needed. Number 3, pause is needed. Recall that the GCF is the same as the greatest common divisor, and so these are the directions for that. So I'll bring up the calculator. Let me clear that screen there. Again, under math and over to the num column. Number 9 is the GCD. So I'll find the greatest common divisor or greatest common factor of 45, comma. Again, bring up math over to num and down to number 9, greatest common divisor of the last two, 50, comma, 84, double right parentheses. And the answer is 1. Now some students would go with 0 because they'll say, oh, they have no greatest common divisors. So there are no greatest common divisors, but there is a greatest common factor, or in this case is 1. Press pause as needed. Number 44, need to read that. Pause the video to do so. Resume when you're ready. So these are the key phrases right here. The 10 minutes is necessary for the solution. But this is essentially, if you think about this, a least common multiple calculation. I want to find the least common multiple of those two numbers. So again, I'll bring up the calculator and math over to num. And number 8 is the least common multiple of 16, comma, 28 seconds. And in 112 seconds, those two people will be back at the starting line together, which is answer G. So using fractions, the next few talk about using fractions and mixed numbers and decimals and so on. Number 11, pause is needed, resume when you're ready. So this one I'm going to use the calculator for this. And he does not participate in more than one extracurricular activity, he or she rather. And so I'm going to subtract 1, or take 1, minus each of these fractions here. So 1 minus 2/3. One way to get the fraction is alpha y equals, has the fraction template in number 1. And so I can put 2, down arrow, 3, right arrow to get out. Minus 1/6. Another way to get a fraction is alpha x is also the fraction template, 1 over 6. Minus 1/10. Again, I'll do it the other way. Alpha y equals where the fraction template is, 1 over 10. And then minus 1/60th. And alpha x, I'll use that here, 1 divided by 60. Enter, and it does the calculation for you. And the fraction of the class that did not participate in any is 1/20th, which is answer C. Number 16, pause is needed. So for this one, what we have to do basically is find the average of those two fractions. So let me go back up here, and I'm going to use the fraction template. And in my numerator, I'm going to add these two fractions, 2/3. So I need a fraction template again to get 2/3. Get out of the denominator, plus. And then another fraction template for 3/4. And then I want to divide that by 2. So that's going to be halfway between those two, the average of those two. And let the calculator do all the work. And it turns out to be 17/24, or F. Look at number 34. Resume when you're ready. So here what I did on this expression right here, this is a positive integer. I factored out the x and got these fractions right here. So what I'm going to use, I'm going to use the calculator, add up those fractions, 1/3, 1/7, and 1/9. So again, it could be alpha y equals to get the fraction template, 1 divided by 3 plus 1/7 plus 1/9. And I'm getting 37/63, which means if this is going to be a integer, the least possible integer, then it has to be divisible by 63. So that would be my answer right there. This would be 63. X would be 63. I could have also just found the least common multiples of 3, 7, and 9. That would have worked as well. I'll leave that for you to try it. Number 20 is kind of a long one. Read it, pause the video, resume when you're ready. All right, so for this one, this is just a straight calculation, and I would hope that my students could add up these mixed numbers with the least common denominator, but I can let the calculator do this. Again, under alpha y equals are the fraction templates. In this case, the mixed number one under number 2. So I can write the first day was 9 as the whole number, and then 1/4. Plus add up the next day, 8, plus the third day, 6 3/4. So again, alpha y equals, the second one is the mixed number, 6 3/4. Plus, and then finally the last mixed number, 7 1/2. I'll add those up. And then I have to multiply that answer, that last answer, by $7.20, 7.2. Put in the 0 if you like. And $226.80, answer F. Notice I did not have to write it as a mixed number to do that. Numeric Solver. Several different problems on Numeric Solver. Go ahead and look at number 36, read it, pause the video to solve it, resume when ready. All right, so let me go ahead and bring up the calculator. So the Numeric Solver is under Math, and it's the last one in Math, so I'll press the up arrow to get to the bottom quicker. That was the up arrow under Math, Numeric Solver. And E1 stands for expression 1, or the left side, E2 expression 2, or the right side. So I'll clear what's there and I'll type in, let's see, these are opposite sides of a parallelogram, AB and DC. So I want to know when they're equal. So I'll go ahead and set those two equal. Again, using the fraction template, 2/3. Now I have to use x, I can't use n, that's for the variable, minus 5, down arrow, clear that out, and I want to know when that's equal to 1/3 x plus 7, so again, fraction template, so I have the left expression here, 2/3 x minus 5, the right expression, 1/3 x plus 7. Notice this OK is above this hotkey. There'll be 5 little menus that could be here. So to say OK, I'll click on Graph. And I need to give it a seed number to start with. It could be any one of these numbers. So 10 seems OK. I'll use that as a seed number. So I'm just going to type a graph again to actually solve it. Okay. And notice I'm getting not exactly 36 because this is using an algorithm, but pretty close to 36, so the answer is K. So the value of n is n equals 36 using the Numeric Solver. Number 53, pause the video as needed, resume when you're ready. Now I'm hoping that my students will try to get these to the same base and think of 27 as 3 cubed and 9 is 3 squared. And then using the laws of exponents, this is 3 to the 3n squared, multiplying power of a power. And 2 times the quantity 5n minus 4 is the other power of 3. And so those are going to be equal with the same base, then the exponents have to be the same. So let's go ahead and use the solver to actually know when these two expressions are equal. So I do need to quit and go back into the solver. So Math up to the Numeric Solver, clear, and Again, it's 3x squared, not 3n squared, but 3x squared. And clear. When is that equal to 10x minus 8? So there's my two expressions. So I'll press graph to say, yep, okay. Now for my answers, I could pick one of these numbers here. Let's maybe go with the one closest to 1. So I'm going to try 1. I say, let that be my seed, my guess. And then I'll press graph to solve it. And it's coming up with that x is this terrible looking decimal. Ooh, that's a 1 there. Let me maybe pull that off a little bit better so you could see it, that 1 better. Okay. And in fact, if you don't know that that's 4/3, what you can do is this number is stored in the variable x, so I can go off to the home screen and type the letter x, and then say alpha y equals number 4 is fraction to decimal or decimal to fraction. It'll convert back and forth. And I can see I'm getting that 4/3. And I could go ahead and solve for the other one, see when it's close to 2. But I don't really need to because that's the only one that has a 4/3 in it. But let me do it just to be sure. So again, back to math, up to numeric solver. I'm okay with that equation. And now I want the numbers that are closer to, let's say, 3 as my seed, and then press graph to solve. And there's my other solution, x equals 2. And sorry, I got blacked out there, but it's 2. By the way, I could have also typed this in as well. Okay. Did I do that on the next one? I don't know. Let me just go ahead and try that. So again, math, up to numeric solver. Now this time it's going to be 3 to that power. Okay. And I'm not really good with editing it. So let's go 3 raised to the 3x squared power. And down here, this will be 3 raised to the 10x minus 8 power. And again, I pick one of these numbers for my seed. So let me try maybe -4, since that's there. Let me try -4 for a seed. And there it is. It's giving me 1.333, whatever. Okay, so you could also had used the equation the way it was originally, though I think I would really like my students to be able to do it without the solver, but in case they need to, that's where we would be. Press pause as needed. All right, number 17, pause the video to read it, solve it, resume when you're ready. So for this one, I'm going to let a variable represent the minimum number of free throws to make to be able to increase the percentage to 80%. And getting the equation is, to me, is the key thing. It's going to be 46 over 60, but we're going to add x free throws out of the 46 and also x free throws out of 60 because she's going to make all of them in a row. And it's going to have to be equal to one of these expressions right here. And again, I think setting this up was the key to me. Since they know they can use a calculator, I think it would be a good idea to use the calculator, to use the numeric solver to get this. So again, my left-hand side will be this rational expression, 46 plus x, divided by 60 plus x. And the second expression, I can't really type in 80%, but I can type in either 4/5 or 0.8 and say OK. And for my guess, I'll type in, let's say, 2 and see where we get. And it looks like we're getting 10. So the answer is C. Now again, I would hope my students can solve this by hand, but you know, they can use a calculator as well. Number 57, pause is needed. So this one's going to require a little bit of algebra first. Interest equals principal times rate times time. The time is 1 year, and I'm going to let the rate be x, a percent as a decimal. We don't know what that rate is. So my equation becomes I equals the principal times x. And we know the interest is $372, so it's going to be pi times x. And that means that solving for p, we're going to get 372 divided by x is capital P. But this is what we also want. In a year, we're going to have a $434 in interest if we increase the rate by 1%, 0.01. So what I'm going to do is substitute into that equation right there and get 434 is equal to this expression in terms of x times this quantity. So instead of having two equations with two variables, one equation with one variable. And I think solving this with the solver is exactly what I would want to do here, just for time's sake. Okay. Again, you could be able to do this by hand, but if we're allowed to use this and they know you're allowed to use this, encourage that. So 434 on the left for expression 1. And let me clear that. And a fraction template, 372 divided by x times the quantity of x plus 0.01 parentheses. And let me double check that. Okay. For my guess, now this is remember my x is a rate of interest, so I'm going to go with something like maybe 0.05 as my guess, or 0.04 maybe as my guess, and then press graph to solve, and it turns like it's 0.06 is my interest rate. Now, that is not my answer, okay? 0.06 is not my answer. That's my interest rate. I'm going to have to find out what P is so I can substitute into either one of these formulas. I think this one would be easier. So 372 divided by 0.06 should be my answer. So off to the home screen, fraction template, 372 divided by 0.06. I could also put the x there if I wanted to. $6,200. Letter E. So this is solve and think graphically and by table, not just algebraically. So we have several questions to illustrate that idea. Number 9, pause is needed. I'm hoping my students can solve this algebraically, but let's look at it graphically. So I'm going to go to y equals and type in that expression there, left parentheses, 2x plus 5, right parentheses, left parentheses, 3x minus 4. And I'll just use a zoom standard, the zoom standard, negative 10 by 10 in each direction. And you can see that we have x-intercepts at somewhere between 1 and 2, and somewhere between negative 2 and negative 3. So I think just by process of elimination, we could go ahead and eliminate this one. We can eliminate this one. We can eliminate this one. And we can eliminate this one and this one. That's it, okay, just by looking at it, okay. However, I think it might be a good idea if we looked at the zeros and traced to some numbers. So if I would say trace to, let's say, positive 4/3, I could just type in 4 divided by 3. And you can see that it is a 0 there. And I also could do negative 5/2. So I can also type in negative 5 divided by 2 for x. And it's going to say y is equal to 0 there as well. So it's just a way of graphically looking at the solutions. And I like my students to be able to visualize things graphically there. Number 43, pause is needed. So what I would suggest is we're going to find the equation of this line, and I would like to use the two easiest points, and I think it would be the intercepts that are listed there. We also know that the y-intercept is -3 from this one right here, okay? So go ahead and find the slope, and the slope turns out to be +1/2 using these. I think these are the easiest ones to use. So here's our equation. So what I would suggest is go back and type in, that is our equation, 1/2 times x minus 3. And I'll go ahead and graph that with zoom standard. And now I can go ahead and see which other point is on there. So I can go ahead and use trace again, and I could trace to -3. And when I do that, it's not -4. Okay. I could trace to -1. Not -4. +1, not -2. 4, 4 is 1. 4 is -1 rather. There it is. Looks like I messed up my window a little bit, but that's okay. All right. So I can see that the answer is D. Okay. I also could have used table here. Let me just show you how you could use table here, using a feature not many people realize. If you go to set your table and put the independent on ask mode, press enter on ask mode. All right. Now when I go to my table, there's nothing there. It's waiting for me to ask. So I'll type in -3, not -4, -1, not -4, 1, 4. Bingo. There's our answer. I'll even try 9 and show that 9 does not work. So here's another way of doing that, either using the graphing calculator to trace onto a line or use the table ask mode. Okay, one of my favorite things to do when I need to use it. Number 45, read that one, pause is needed. So for this one, we'll do this graphically. In Y1, I'm going to type in this expression right here. And I need to get a window for this. And by guess and check, this is the window that I came up with. So I can go ahead and graph it. And then I need to find the maximum value. So that would be under second trace is the calculate menu. And number 4 is maximum. Now it wants a left bound and a right bound. I'm just going to, it looks like it's about right there anyway, but I'll just go to the left a little bit of where I think the maximum is, press enter. I could also type in a value for x instead for the right bound. I'll just say that's the right bound, and my guess, any number in that interval. And it turns out that x is equal to 200. And the reason it's not exactly, as again, this is an algorithm, something like Newton's method that would use me approximate this. So 200, D would be the answer. Press pause as needed. Number 21, pause the video as needed. So for this one, I went ahead and solved both equations for y. The red one was already solved for y. The blue one divided each term by 3 and got this. And this should tell students that these lines are parallel and they have different y-intercepts. But in case they don't, it would be a good idea to show that. So I'll type in 2x plus 4 into y1 and 2x plus 6 into y2. I'll do a zoom standard, zoom 6, -10 to 10 in each direction. And you can see that there is no solution there. Okay. You could also go to the table and see the table. I'll be in a regular table mode, and you can see that in the table for each value of x, the y1 and y2 are never equal, and they're always 2 apart because of that +2 from +4 to +6. Number 41, pause is needed. So for this one, I'm hoping my students can just visualize these as graphs, if you will. So I went ahead and already graphed them, the left side in blue, the right side in red, and you can see that these are not the same, these are not the same, these are not, and these made purple, so they were exactly the same, and these were exactly opposites of each other. So D is the correct answer. And then it makes sense. The absolute value of a number is always equal to the absolute value of its opposite. Think of it if it's the opposite instead of negative. Number 58, pause is needed. So we want to know when this has no real solutions or imaginary solutions. So that would be when the discriminant is negative. So that would be b squared minus 4 times a times c is less than 0. And for this one, a is 1, b is b, and c is 1. So when I substitute in there, I get b squared minus 4 is less than 0. And the traditional way to solve that would be to factor it, get zeros and make a number line, see where it's positive, see where it's negative. And but another way would be you can actually solve this inequality with your graphing calculator. So let me show you how you do that. So in Y3, I'll use the black here. I can type in, instead of b squared, I'll type in x squared minus 4. And I want to know when that is less than 0. So under second math is the test menu for the inequalities, second math. And number 5 is the strict inequality, less than 0. And I know that looks kind of weird to you, okay? To type in an equals with an inequality almost looks like bad grammar. But when you graph it, it shows you where that solution is. And that would be the numbers between 2 and negative 2. And then you have to know it's not inclusive by the strict less than sign. So here's a way of seeing that graphically. Okay. So the solution is letter K, the real numbers between negative 2 and positive 2, not inclusive. Transformation graphing is something that is tested on the ACT and SAT. Pause is needed. Now I know you could graph all of these. That would take some time to graph all of them. But hopefully you're thinking graphically here. These are the parameters. A is negative 2, H is negative 2, and K is positive 5. And remember that the A being negative means it's going down, and the 2 makes it narrower. The H, x minus and negative 2 means it's going to be shifting to the left 2 units, and up 5 for the positive 5. So normally I would be at the origin. If I go left 2 and up 5, that would be the vertex. Left 2 and up 5. That's a possibility. That's a possibility, and that's a possibility. But the narrowest one is right here. So if I go left, right 1, and down 2, 2 down 8, this looks like it right here, E. Okay, this is the narrow one, and it's been shifted left 2 and up 5. This looks like it would be x squared. This looks like it would be a half x squared. So the answer is E. Pause is needed for number 51. So let's look at the parameters here. This is a generic piecewise function, okay, not one that people really know. Okay, so we're trying to see if you understand transformations generically. So H is positive 3, K is positive 2. And if H is positive 3, that means this graph is shifted to the right 3 units, and the plus 2 is up 2 units. So what I'm going to do is I'm going to pick a point on here and shift it right 3 up 2. So I'm going to pick this point right here and go right 1, 2, 3 and up 1, 2. So this point would translate to the point 2, 2. So where is this point going to be at 2, 2? Right there at E. So E is our answer right there. And it would work not just for this point, but any point would have worked. Okay, so letter E. So since you're looking at transformation graphing, I'm doing another talk at this conference on transformation graphing, and I've created, along with Texas Instruments, this website that has over 250 animated videos. This would be a quick link to get there. There's a quick reference guide. If you look at that, if that's for you, great. If it isn't, fine. This would be something your students could use. Pick out which types of graphs they need to practice, okay? So I strongly urge you to look at that right here. Composition of functions is another thing that's tested on the ACT. Number 18, pause is needed. So for this one, I'm hoping my students can do this algebraically, find f of g of a variable of x. But to look at this graphically might be a good way just to have them visualize it. So I'm going to type in 2x minus 1 in y1, where that would be the f function, and x squared plus 1 in the y2 for the g function. And since I don't want to graph these, I'm going to turn them off by pressing enter on top of the equal sign. They can be referred to, they just will not appear on the graph. And y3 is going to be y1 of y2 of x. So alpha trace is where the y variables live. So that'll be y1, left parentheses, alpha trace, y2, left parentheses, of x, and then double right parentheses. So this is my f of g of x right there. Again, I'll do a zoom standard. And there's my graph of f of g of x. Now looking at that graph, you can see there's a y-intercept of positive 1. The only one that has a y-intercept of positive 1 is g. Number 50, pause is needed. So this one you work inside out. I'll first find g at 1, which from the table g evaluated at 1 is positive 2, right here in blue. I'm pointed in blue. And now I'm going to take f at that answer, and f at 2 is negative 6. So the answer is f. This one could not be done with a graphing calculator, but it went along with the composition of functions. Complex numbers can be done on graphing calculators, and I'm not sure why they would even test this on the ACT, but let's go ahead and look at that. So number 36, pause is needed. So go ahead and bring up the calculator, go off to the home screen. It doesn't matter what mode you're in. Some people think you might have to be in A plus BI mode. You do not have to be in that mode to do this problem. So I'll go off to the home screen and I'll just type in what I see there. A left parentheses, 7 plus 6. I is blue above the decimal point, so that would be second decimal point to get the I for imaginary, not the letter I, not the capital I. Right parentheses, and then the squaring key. And press enter, and answer H is the correct response. Number 39, pause is needed. Again, we could do this with a calculator, which surprises me why it would even be on the test. Bringing up a rational expression here, 2 plus 3i. Again, the I is second decimal point to get the imaginary I. And the denominator is 1 minus 2 second decimal point for imaginary I. And there is our answer right there. Negative 4/5 plus 7/5 I, which is letter E. The next section is matrices. Number 30, pause is needed. For the solution to this one, I'm hoping my students can do this by hand, but in case they can't, second X inverse is the matrix key, and I want to edit matrix A. I want it to be 2 rows by 2 columns, so 2, enter, 2, enter. And then I'll type in the numbers, 3, enter, 5, there's the first row, enter, negative 2, enter, 1. So matrix A is now in there. Again, I'll go back to second matrix, go over to edit and down to matrix B, enter. It's already 2 by 2, so I'll just hit enter on the 2s. All right, starts off with a negative 4, enter, 5, enter, 2, enter, 1, enter. And so now they are in there, okay. So now we're ready to go ahead and multiply matrix 2 or matrix A by 2. So that'll be 2, then second X inverse, and we're under name, so 1, matrix A, minus 3, second X inverse for matrix, and then the second one is matrix B. So it's going to take those matrices, do the calculations, and there's our answer, which is letter F. Now, alternative way here would be looking at a good procedure here, strategy, would just be to double the first element in A and triple the first element in B and subtract them and get 18, because that's the only one that has an 18, and you only had to do one pair of calculations instead of 4. So that's another alternative there. Number 18, pause is needed. Now we could go ahead and enter the matrices and subtract them, okay, A minus B or whatever matrices you wanted to use. But as an alternative, I'm suggesting just taking the first and subtracting 10 minus a negative 9, which is like 10 plus 9, which is 19, and K is the only one possibility here. So again, a strategy. Mean, median, mode, and range come up, but a little bit differently than used to. So here's number 26, pause is needed. So it says an outlier is added, so I'm picking a huge outlier to really make obvious that it's an outlier. And then what we want to do is decide which of the following pairs have no change in value as a result of this outlier. Okay, so right away, the 1,000 is definitely going to affect the mean. So I can throw out F, G, and H. Okay, and the 1,000 is also going to affect the range. So that leaves median and mode just from that. However, you can see that the median for this one is going to stay at 72, and the mode is going to stay at 73. That 1,000 has nothing to do with it. So a couple different strategies on that one. One of my favorite exercises on dealing with mean, median, mode, range is this one. Pause is needed to solve it. Resume when you're ready. So for this one, I would create 5 slots for the 5 numbers. And I would put in the median, 6, right in the middle. The mode is 7, by the way, left to right, smaller to larger. So 7 would go in the last 2 slots. It's a single mode of 7. There's only one mode. The range is 6, so 7 minus what is 6, so that would be a 1. And so now the mean has to be 5. I'd have to add these up and make sure that they divide equally by 5. And it turns out that the missing number there is 4. So here are 5 numbers that satisfy all those requirements. And I love this problem because it tests all those ideas in one problem, but not just calculate them. They have to really think about what they mean. Press pause as needed. The rest of the problem's solutions can be found either in the PDF of the solutions or on the second video that is on the website. I really hope that you got some good ideas to use with your students. If you want to, let me know what you think. That's my email address. And remember, this is where all the materials are. Have a good one.